Welcome to section 6.1. Our objectives are I can classify polygons based on their sides and angles, and find and use the measures of interior and exterior angles of polygons. So lots of terminology today. Starting off, we have sides, which you should already know, but the sides are just kind of the edges of any shape. The vertex is the points where they meet, the pointy parts, and then the diagonals are anywhere crossing through those vertices. So if I were to connect this vertex to this vertex, that would be a diagonal. This could also be a diagonal. So the diagonals just kind of connect the vertices. Vertices is the plural vertex, by the way. Here are some names that you should either write down or memorize. Some of these that you already know. But if it has 3 sides as a triangle, you already know that. 4 sides is a quadrilateral. Quad meaning 4. So if you were to go out and write a quad, it has 4 wheels. That's why it's called that. Just like a tricycle, it has 3 wheels. If you have 5 sides, you have a pentagon. Penta meaning 5. 6 is a hexagon. A popular hexagon is, oh, never mind. I was going to say a stop sign, but that's an octagon. 7 sides would be a heptagon. Hepta meaning 7. Octagon meaning 8. 9 would be a nonagon. 10 would be a decagon. Think of decade means 10 years. And then 12 would be a dodecagon. And do recognize that there's no 11. It's because 11 or anything further after that is called an n-gon. So if you had 11, it'd be an 11-gon. If you had 20, it'd be a 20-gon. And if you had 100 sides, it'd be a 100-gon. They're just the various names. You will see these in word problems or any other type of problems, and you'll just have to know how many sides they're referring to. So recognize these root words, a little bit of English here, but like octagon, you should know octa means 8. You think of an octopus has 8 legs. A pentagon is kind of like a house, a penthouse. So just think of those root words and you'll get it. And my thing is messing up. There we go. Okay, so any polygon needs to be a closed figure. So if you had something like this, like an open box, that is not a polygon because it's open. If you had like this, that's also not a polygon. This is a circle. It's not a polygon because it is curved. You don't want any curves, you just want straight segments. So that's not a polygon. This would be a polygon. This could be a polygon. That could be a polygon. Just make sure that they're enclosed and they don't have any curves. So look at this. It is enclosed. It doesn't have any openings. It has no curves. And so it is a polygon. So yes, it's a polygon. We'll say yes. That's the first part. Tell whether it's a polygon. And then if it is, which it is, name it by the number of sides. The number of sides are 1, 2, 3, 4, 5, 6. So if you have 6 sides, what's the name of the polygon? This is a hexagon. Hexa meaning 6. Okay, our next one. Is this a closed shape? I don't see any openings, so yes. Does it have any curves? It does not, so yes, it is a polygon. Just remember, a polygon needs to be closed with no curves. And then how many sides does it have? So 1, 2, 3, 4, 5, 6, 7 sides. How many sides was the 7-side one? How many sides? What was the name of the 7-side one? This is a heptagon. Wow, I don't know how to spell today. Heptagon. Okay, what about this one? Is it enclosed? Yeah, I don't see any openings. And is it not curved? Ooh, it's very curvy. So no, it's not a polygon. And since it's not a polygon, I can't name it. So that's it. No, it's not a polygon. Okay, what about this one? Is it closed? No, there's an opening right here. So that is not a polygon. And I can't name it if it's not a polygon, so that's it. Okay, what about this one? It looks closed. I don't see any curves. Okay, so yes, it's a polygon. And let's see how many sides it has. So 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. 9 kind of sounds like nonagon. Nonagon. That's what a 9-shaped or 9-sided shape is. A nonagon. Okay, what about this one? It looks enclosed. Ooh, but it has a curve right here. So this is not a polygon. So now let's talk about a regular polygon. So you can have all kinds of polygons, but a regular polygon has the same side lengths and the same angle length. So it's equilateral and equal angular. The first one I think of is a square. It's got equal sides and equal angles. All the sides are the same, all the angles are the same. If you were to have a pentagon, it could look like this, where all the side lengths are the same and all the angles are the same. So these would be regular polygons. If you had one that looked more like a house, see you have right angle here, and these are different up here, as opposed to that one. And the side lengths don't look different or don't look the same anymore. You got like 9 here, maybe 8s here, 7s here. The side lengths are no longer the same. This would be irregular. So you have an irregular shape and you have regular polygons. So regular polygons are equilateral, same sides, and equal angular, same angle measures. Okay. You also have 2 more words, concave and convex. So concave, it kind of caves in. You could tell if it's really concave by connecting 2 vertices. So I have a vertex here and a vertex here. And when I connect them, I notice it's not inside the shape. It connects outside the shape. So that's a good way of checking to see if it's concave. Convex is kind of like if you were to hook a pump to this, and this is like a little bicycle pump, yeah, and to blow it up fully. And so that way, when you have your vertices and you connect them, the diagonals are inside the shape. So convex is fully pumped up, concave kind of caves in. You can check through the vertices. All regular polygons are always going to be convex. So looking at this one, let's first tell if it's regular or irregular. So if it was regular, it would have all equal sides, which it does, and all equal angles. Does it have all equal angles? Looks like these are the same, but these ones aren't, so it's irregular, because it needs to be both equal angular and equilateral. Okay, is it concave or convex? Well, if we were to draw the diagonals, it looks like they're all on the inside, and it doesn't cave in anywhere, so this is actually convex. Convex. Okay, what about this one? Is it regular or irregular? Well, it looks like I have a lot of right angles, but it also needs the same side lengths. It looks like this one's pretty long, top and bottom, but these little guys kind of make it not the same side lengths, so this is irregular. Okay, is it concave or convex? Well, convex would be everything on the outside, but if I were to connect this vertex and this vertex, it's on the outside the shape, which shows me that we kind of dented it in there a little bit. It caved in, so this is concave. Okay, is this regular or irregular? Well, all the side lengths are the same, making it equilateral, and all the angles are the same, making it equal angular. So this is a regular polygon. This is actually a square. Now, is it concave or convex? Well, I don't see it caving in anywhere. If I were to connect these vertices, they're all on the inside. Those diagonals are on the inside, so it's convex. Okay, regular or irregular? Looks like it's equilateral, looks like it's equal angular, so we're regular. Concave or convex? Well, if I were to draw all my diagonals, they would all be on the inside, and it would make this fancy star. Ooh. Yeah. I I messed that up. I don't know what I did. Oops. There we go. Fancy star. So this is actually convex, because all of those diagonals are on the inside. If they were on the outside here, it would be concave, but because they all connect on the inside, it's convex. Okay, regular or irregular. It doesn't look like it's equilateral, so we're irregular. And concave or convex, well, these connected would be on the outside of the shape, or you could think of it as it kind of caved in there, so it's concave. Okay, now let's talk about angle measures. So first of all, we have a triangle. Now, silly question, how many triangles are in one triangle? There's one triangle, right? It's one triangle. If I were to connect or make a diagonal here on a quadrilateral, how many triangles do I have now? Well, I have 1 and I have 2. How many sides does a quadrilateral have? It has 4, so it has 4 sides and 2 triangles. Okay, we're just going to play around with this for a second. How many sides does a pentagon have? It has 5 sides. And how many triangles are drawn there? If I were to make triangles within, how many triangles do I have? I have 3. How many sides does a hexagon have? It has 6 sides. And how many triangles do I have within? 1, 2, 3, 4. 4 triangles. Do you notice a pattern? Well, the number of sides minus 2 give me how many triangles are inside. So I had 4 sides, I subtract 2, I get 2 triangles. I had 5 sides, I subtract 2, I get 3 triangles. I had 6 sides, I subtract 2, I get 4 triangles. Okay, so the number of sides minus 2 gives me the number of triangles. Now, how much, let's talk about angle measure wise. How much is the total angles in the triangle? So if like this was 60 and 30, what would my last be? Well, it's not proportional, but it'd be 90, right? Because you know that the triangle adds up to 180. So the number of sides minus 2 gives me the number of triangles, and if I multiply that by 180, that would give me the total angle measures of the polygon, which is our actually formula right here that we're going to look at. This is how they got it all together. We're just looking at the formula. So if you want to write the formula down, you can. But that's how we got the formula. So if you forget, you could always do that. You could draw a shape like this, and you could just make your triangles. I have 2 triangles here. So if this is 180 and this is 180, you just add them up, right? Super easy. So n minus 2 times 180 gives me the total sum of the angles within. So if I was trying to find this, and this together, well, you add 180 and 180, get 360, which we know is the total angle measures of a square. Let's do some practice problems. I might be losing some of you. Okay, so let's find the sum of the interior angle measures. So that's what we were talking about. Of a convex, okay, convex is not important, heptagon. This is where knowing the word comes in handy. So hepta means how many sides? 7. Okay, so in my formula I have an n. N stands for the number of sides. So I just plug in 7. So then I have 7 minus 2 times 180. So 7 minus 2 is 5. And I times that by 180. I can do it that way. And I get 900 degrees. And it just asked for the sum. So 900 degrees is my answer. Okay, if you like plugging into formulas, this is your thing. Okay, and pay attention to the fact that we said interior angles, because we will be talking about exterior angles in a little bit. But interior angles, this is your formula. Okay, but this time we have a 16 gon, which means I have 16 sides. So I just plug it in right there. So 16 minus 2 times 180. So then that's 14 times 180. And I get 2,520. Now, looking back at our original question, it said the measure of each interior angle. So if this is the sum of all the angles, how do you think you'll find each angle? Well, if we have 16 sides, we also have 16 angles. So if I were to divide this by 16, I would get each angle. And that's the nice thing about these, is because these are regular polygons, and you'll only ever have regular polygons unless they give you a picture. And so you will have an even amount that will be equal angular. So you can just divide this and it will come out nicely. So all of them are going to be 157.5. Let me just double check that. Yep, 157.5 degrees. Each angle will be the same because this is an equal angular polygon. Okay, so find the measure of each interior angles. This time we have a picture. It looks like some of them are different. This is not a regular pentagon. So first of all, we need to find out the total, right? So we have a bunch of C's here. It might help to figure out what the C's are. So figuring out the total measure of all of these would be our formula. Okay, and this is a pentagon, so we can just plug in 5 there. So then we get 3 times 180. We have 540. Okay, so all of these added up together, it's 540 degrees. Now, if I were to take all these and add them up, so all of them added up, they should equal 540. Now you might be wondering, what does this do for me? Why am I doing this? Well, we have an equation. We can actually solve for C now. So you have all your like terms here. Just add them all up. So 18 plus 18 plus 35 plus 32 plus 32. You get 135. C. See, I just combined like terms, and now it's a lot simpler of a problem, isn't it? So then you just do 540 divided by 135, and you get 4. C equals 4. Now, we were trying to find the measure of each, so we're going to take that C, and we're going to plug it back in. So 35 times 4, this angle is 140. 18 times 4, you get 72. And this one's also 72 because it's the same. Okay, and 32 times 4, you get 128 for both of these. Now, if you didn't feel like going through the picture and pointing, you could say angle C equals 128 degrees. You guys know how to write those. Angle A equals 140 degrees. You could write it that way. But those would be the answers they're looking for. Okay, now we're back to just words here. So find the sum, the total, just using a formula of a 15gon. So 15 is the number of sides minus 2 times 180. So then we have 13 times 180. 2,340 degrees. Okay, and this one was another one of each. So we're going to use our formula again, n minus 2 times 180. And so a decagon has how many sides? Has 10 sides. So 10 minus 2 times 180. So that's 8 times 180. And you get 1,440 degrees. Now it asks for each, so what are we going to do with that? Because this is the total. I have 8 sides, and therefore 8 angles, so I'm going to divide this by 8. And I get 180 degrees for each. So look for those key words. Okay, exterior angles are very, very easy. They're always 360 degrees, no matter what. Okay, they're going to add up to 360 degrees. So before we had our fancy formula for the interior, exterior are always going to add up to 360. Now, exterior are kind of weird. You take the vertex and the side and you just kind of extend it. It's kind of weird. It's kind of like a little tide pool. But it always adds up to 360. All the things I just said. Okay, so find the measure of each exterior angles of a regular 20gon. So if you have 20 sides, and they all add up to 360, you can just take 360 and divide it by 20. Donezo. Okay, this one, remember, they all add up to 360. So you would take all of these and b is like the worst variable you could possibly have because it looks like a 6. These all add up to 360. And just remember, you can combine like terms. So 33 plus 16 plus 10 plus 28 plus 15 plus 18 is 120. And this is a b, not a 6. And then you do 360 divided by 120. 3, b equals 3. And they just wanted the value b. Perfect. Okay, and you notice that these problems tend to repeat. So you just kind of get used to them. Exterior, all of them add up to 360. Interior, you have your formula. The measure of each, okay, we're going to be dividing exterior, so it adds up to 360. So 360 divided by something. A dodecagon has 12 sides, so 360 divided by 12. And what do we get? 30. And don't forget to say degrees. Okay, and last one, find the value of r. So we got our exterior angles are going to add up to 360. And let's add them all up. 4 plus 7 plus 5 plus 8. So you just add them up. Get 24r. You do 360 divided by the 24. You guys know how to do these simple algebra things. You guys passed algebra and gone here. So r equals 15. And if you're not sure, you can always plug it back in and check. There you go. There are our polygons.